Okay guys, what's Gucci everybody? And today I want to talk about a new method of adding or inserting elements into a hash table, and that is called chaining. And this is where the table elements are referenced in a linked list that contains all the items that hash to the same table index. The linked list is often known as a bucket. I'll just type that in instead of you guys seeing my horrible handwriting. And this is sometimes called bucket hashing. So let me show you guys a little picture here. So I'm still going to have my array or storage facility, as I like to call it, but instead each index is a bucket, and that bucket is a linked list. So this is 0, we'll say 1, 2, 3, 4. And let's say I add an element with hash code 1. That's going to go to a linked list, or a node, as I like to call it, that contains the data. And if you don't know what a linked list is, I probably do have another tutorial on it, or you can Google it. It's just a list. It's just another way to store data that's connected to each other, or each nodes have reference to the next node in a list. And so if I add another element with hash code 1, I simply add that to the linked list. I can add it to the end or the beginning. It doesn't matter. Usually I would prefer to add it to the end for clarity. And chaining in hashing is good for a few reasons. I don't have to worry about dummy values, because let's say, for instance, let me draw another chain. So I have a node at hash code 3 here, and basically when I want to delete something, I just can delete it. I don't have to worry about dummy values or anything, because I check this hash bucket, and then I run through the linked list, and if nothing is there, then I can assume that it's not there and return, hey, this key was not found. And so that's what's nice. I don't have to worry about dummy values. And it's not that hard to look through a linked list, but a problem could arise if one of the buckets is extremely huge. Searching through it could take a very long time and could make you big O of n for that hash, not constant time, but linear time, depending on the length of the bucket. Now, what are the good things about chaining? Go away, stupid YouTube upload video. And a great thing about chaining versus linear probing, as it's called, or the method I've showed you guys the other way, which is known as probing, in which you increment and wrap around and use dummy values, is that it's much better when your array, this thing, is almost full. Because in linear probing, let's say I have almost a full array here. It's like 90% full. If I have almost a full array, when I keep on incrementing, I have to increment a lot, or maybe almost the whole way, to figure out where I can store my element or find the indicated element. But when my chaining table is almost full, that's okay, because I just am adding it to a linked list. So I'm not filling up the table, I'm filling up the buckets. So I'm adding something to the buckets, but the buckets you can always add a new element, because these linked lists aren't arrays, they're linked lists. So I'll create a new node and insert it. So that's the beauty of chaining, is that it doesn't really care if it's getting really full, and it still has really good performance even though it's almost full, whereas probing can get very ugly when it's not full. So yeah, that's chaining. That's the beauty of chaining, is that instead you're using buckets instead of storing everything in their index. And the buckets are linked lists, which link to each node that is stored at that exact index, and you can add to these buckets, or you can delete from these buckets if you need to. And you can also get information from that exact node, which is the beauty of it. Well, guys, I hope you have a great day and you enjoy chaining and think about it. I'll see you guys later.